At some point, you're going to break your code. One small change, and suddenly everything stops working. And you'll wish you could go back to how your project looked 10 minutes ago. That's exactly what Git does for you. Git tracks every change in your project so you can rewind to any previous version, and it lets multiple developers work on the same code without overwriting each other. The key idea is simple. Git doesn't just save your files, it saves snapshots of your entire project at different points in time. Each snapshot becomes part of a timeline, and at any moment you can jump to any point on that timeline without losing anything. That's Git in a nutshell. Before looking up any Git commands, you need to understand the Git workflow, because without this, nothing else will make sense. So when you're working in a Git project, your files are always in one of three places. First is the working directory. That's where your changes first appear. You open a file, you type something, you save it. That change now lives in your working directory. Git can see it, but it hasn't done anything with it yet. Then there's the staging area. When you've made some changes and you're ready to save them, you move them here with git add. Think of it as a box you're packing. You're telling Git, this change, I want it in my next save. The reason this exists is so you can be deliberate. Maybe you changed 5 files, but only 3 of them belong together. Stage those 3, commit them, then handle the rest separately. And finally, the repository. This is where the actual history lives. When you run git commit, everything in the staging area gets packaged into a snapshot and stored in the project history. So the loop is, change happens in the working directory, you move it to the staging area with git add, you lock it into the repository with git commit. That loop is how you build your project's history. A commit is just one of those snapshots, and each one comes with the author of the change, a date, and a message you write describing what you did. It also gets a unique ID called a hash, so Git can always find it. Branches are where Git gets really powerful. Picture this. You're 3 days into building a new feature. Your code is half done. Then a critical bug hits production and you need to fix it, right now. Your half-finished feature is all over the codebase. What do? This is what branches solve. Instead of working directly on main, you create a branch, a separate line of development. You do your work there. Main stays completely clean the whole time. Bug comes in, switch back to main, create a hotfix branch, fix it, merge it, ship it. Then come back to your feature branch exactly where you left it. Nothing lost. And when your feature is done, you use git merge to bring it back to main. Git combines both branches automatically. If the 2 branches change the same lines of code, Git flags it as a conflict and asks you to decide which version to keep. Otherwise, the merge is done automatically. Everything so far lives on your machine. That's fine alone, but with a team, or if you just want a backup for your code, you need a remote. A remote is just a hosted copy of your repository. GitHub is the most popular. To interact with remote, you'll be using 3 commands. Git clone. You use this once to download a remote repo to your machine for the first time. Full history, all branches, everything. One command. Git push. Sends your local commits up to the remote. Until you push, your commits only exist on your machine. After you push, they're on GitHub and your team can see them. Git pull brings down the latest commits from the remote. Do this every time you sit down to work. It makes sure you have your teammates' latest changes before you start writing new code. Alright, now I'll be showing a practical example. We're building a simple application from scratch. I'll initialize the repo, make commits, work on a feature branch, merge it, and push it to GitHub. Every step exactly like you would do it on a real project. First, we'll create a folder for the project. Then we'll move into that directory, and then we'll initialize a Git repository. This creates the hidden .git folder where Git stores the entire history. We'll use git status to show the current state of the repository. Empty repo, nothing tracked yet. Let's create the home page. Git sees the file, but it's untracked. That means it's not part of the repository yet. I'll stage the file using git add. This moves it to the staging area. Now it's staged and ready to be committed. And now I create the first commit, the first snapshot of the project. Git log shows the commit history. Right now, there's only one commit. We'll create a second file. Now Git shows one unstaged change. We'll execute git add to move it to staging area. The file is staged and ready to be committed. And we'll create another commit describing the change. Now the history shows two commits. This is the core Git loop. Change something, stage it, commit it. Now let's work on feature on another branch. We'll create a new branch for this feature and switch to it using git checkout-b. The new branch starts from the same history as main. Git status shows the current state of the branch. We'll add a new README file. Git shows the new change in the working directory. We'll stage the new file. Now it's ready to be committed. And commit the change to this branch. Git log shows the commit is added to the new branch history, but the main branch is still behind by one commit. Now I'll switch back to the main branch. Notice the last commit isn't here. It only exists in the feature branch. Now, to merge the feature branch into main, we execute git merge feature-branch from the main branch. And now the commit appears in main as well. Last step. I've created an empty repo on GitHub. Let's connect it to our local repository and push our changes. Git remote add origin connects the local repository to the GitHub repository. And git push command pushes the commits to GitHub. Back in GitHub, we can see the changes we made locally are now saved on the remote repository. To pull the latest changes from the remote to our local repository, we use the git pull command. Now we'll delete the repository from our local machine. To clone it again, we need the remote repository GitHub link. We'll use git clone to create a full copy of the remote repository on our machine. As we can see, the clone repository have the same commits we pushed to the remote ourselves. And that's the foundation of Git. But honestly, we've only scratched the surface. Git has a lot more to offer: merge conflict resolution, rebasing, stashing, tagging, and more importantly, how real teams actually collaborate using it. Pull requests, code reviews, branching strategies, that's where things get really interesting. If you want a video covering all of that, drop it in the comments. If enough of you ask for it, I'll make it. If this helped, like the video. It helps the channel a lot. Subscribe if you want more. See you in the next one.